Okay. All right. So what we are going to do is we are going to start talking about the rest of the periodic table. I have some notes for you.
So we don't have our notebook?
No, because I'm going to have this. There's so much information. Wanda, please stop.
Oh, sorry.
There's so much information that I have that it's just better if I give you the handout for you to fill in information so you can listen to me while I'm going over the information.
I thought this last period said it didn't take so long to
I'm sorry, if you don't have one that's stapled. Copy machine. Okay. At the end of the class, we will go over the lab that we did yesterday. I want to make sure that you got the right answers to the questions and that you understood what we were talking about. Okay, so at the very top of your notes, I have a little bit of review for you. It's not on the slides. I went ahead and added this to your notes because I wanted you to review. Oh, I'm sorry. I forget you. I wanted to review the subatomic particles with you. Remember that when I say subatomic, that means smaller than the atom. Okay. So all of our subatomic particles are your protons, your neutrons, and your electrons. So at the top of your notes, what I have is you have a proton, and what is the charge on a proton?
Positive.
Positive. Come here, baby. It is, sorry. It's positive, good. You don't know what the little plus means, that's what that means. Neutron. Neutral, good. I usually put a 0, just because that stands for no charge, but neutral is fine. And finally, electron. Negative, good. So, where are the protons and the neutrons located?
Middle.
What is the middle called? It's the nucleus. Thank you. Awesome. Good. Y'all are really good. And electrons? On the outside, right? Well, you guys are used to it being called the electron cloud, and you are not wrong. Today in chemistry, we are going to start talking about it in terms of orbitals, energy shells, energy levels. These are all different terms that mean the same thing. So, I'm going to put energy levels. You can put orbitals. You can put energy shells. You can put any of those things, and they're all going to refer to where our electrons are located. So, to start off, we're going to review how to read the periodic table. You guys are probably very familiar with this. However, this is what we start with on your notes. So, as soon as my projector comes up. Okay, I'll turn the light off so you can see. Is anybody familiar with this element? Yeah, that's good. That's fun. This element right here, just letting you know, this element is technetium. Technetium is called the phantom element sometimes because it's unstable. It is, when they discovered it, there's a little story behind it. He knew it existed, but he couldn't prove it. He couldn't find it. So they kind of talk about technetium being a phantom element. So, I just thought it was appropriate. Halloween's coming up. Okay, so the top number that you have is the atomic number. The atomic number tells you the number of protons. tell me what elemental form, what do you think that means? Yeah, form of an element, that's a good.
Like by yourself.
Yeah, by itself, that's true, elemental form. What about up there, what do you know about all of those that are up there? If that tells you that there are 43 protons and 43 electrons, what is that going to tell you about the charge of every single element on that periodic table? It's what? If you've got 43 positives and 43 negatives, what's the charge going to be? Neutral, good. That's what they're referring to all of here. When they say it's elemental form, as it exists up there, it is a neutral element. Everything up there right now has a zero charge because it has equal protons and equal electrons, excuse me.
Hey, I just need to let Tiana Bond know to come by the front office just whenever it's convenient or when the bell rings.
Okay, sure.
Thanks.
So, there is a little acronym for you to remember. In case you don't, you might have learned this in 8th grade, you may not have. A equals P equals E, 8. Atomic number equals number of protons equals number of electrons. Just to help you know, that's what that top number tells you.
I've heard of that before.
Have you? Good. That's good. Okay, so now let's talk about the bottom number. Man. 8 man is a little thing. Yeah. The meaning of this bottom number is that it is the atomic mass. The mass number. You're going to hear it is called the mass number, an atomic mass, atomic weight. They're all the same thing. 3 different ways to say the same thing. So, this tells you the number of protons plus neutrons. This is your protons and your neutrons combined in its elemental form. There again, that's how it exists off the periodic table. And the way that you calculate your number of neutrons is that little mnemonic, man, M minus A equals N. So you take the mass number, you subtract the atomic number, and that gives you the number of neutrons. So, looking at technetium up here, how many neutrons does technetium have? Yep, 55. That's exactly correct. 55 neutrons. You take 98 minus 43, then you get 55. Good. Now, a neutron's charge is what? Neutral. Now, you're going to see some cases in which you have neutrons, they change. And that's called an isotope. We will be discussing those next week. And will that ever change the overall charge of that atom? What's going to happen if I had 100 neutrons in technetium? Would it do anything to the charge? No. Why? Very good. It doesn't matter how many neutrons you have. What do you think that it will do to it? Make the mass what? Bigger. Awesome. It's going to have a larger mass. Awesome. Good job. Okay. So, let's start talking about our trends. First, before we talk about our trends, we have to discuss periodic law. So what does periodic mean? Regular intervals, by the way.
Regular.
Yeah, it's something occurring over and over. So the properties of the elements are periodic functions of their atomic numbers. That's a complicated way to say that as you go through, as your atomic number increases from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, certain properties of the atoms will repeat themselves periodically. That's at regular intervals. This is called periodic law. Sorry. This is periodic law. That as you go through each atomic number, that you're going to have properties repeat each other, repeat each other, and repeat each other. And don't you see that anyway when you look at the groups? Because as you go down the group for every roughly 8 elements, you're going to see that that property is going to repeat. That's periodic law.
It tells you like the outer shell.
Yes, the number of electrons in the outer shells, the valence electrons. talk about rings. You're gonna see how they all interrelate with each other. So our first thing that we need to discuss are ions. Ions are an extremely big part of chemistry, and you are going to have to learn about and use ions for the rest of the year. This is not one of those things that you learn and we don't talk about again. Ions are a part of chemistry. So, here at the top there's a definition of ions, and what it is it's an atom or an element that has gained or lost an electron. That's a short way to say that. But the long definition says it's an atom or molecule in which the total number of electrons is not equal to the total number of protons. So that results in either a net positive or a net negative charge. And we can talk about ions in two different ways. They're either called cations or anions. Your cations are positive. They have a positive charge. They lost an electron, and so they have more protons than electrons. That's how they have a positive charge. That's a cation. And I'm gonna show you examples of how to do this in just a second. And then we have anions. Anions have a negative charge. They gain electrons and have less protons than they do electrons. So this is where it kind of gets a little hard for some students, because it has been ingrained in you since you were in elementary that if you subtract something, then you are going to make it smaller, right? Where it's going to be opposite. If you lose something, it's actually going to be positive. Kind of hard. You have to start memorizing this, and I'm going to show you a method for doing ions and determining if it's a cation or an anion. And I'm going to ask you to do this every time until you get the hang of it, okay? So, here's our first example. We're going to use sodium, which is number 11 on the periodic table. So we have sodium. Sodium is atomic number 11. How many protons does sodium have? If it is a number 11, it has?
11.
Very good, thank you. And how many electrons?
11.
11, thank you very much. So this is sodium as it exists right there. But sodium likes to form an ion. How many valence electrons does sodium have? Say group 1.
1.
1, very good. 1 valence. So, this is where you ask yourself that question. Is it going to be easier for sodium to lose an electron or gain 7? Lose an electron. So, that means that how many electrons will sodium have? 10. Yes, it's going to have 10 electrons. Now, to determine the sodium ion charge, all you have to do is math like when you're adding integers. If you have a positive 11 added to a negative 10, what is your answer?
1.
What? Positive or negative 1?
Negative.
1.
Positive 1.
Okay.
It's okay.
It's okay.
Positive 1. Good. So that's the charge of sodium. That's how you determine the charge of the sodium ion. This is a cation. It's positive. This is a cation because it's positive. Now we'll do an anion. Let's do chlorine. Chlorine and sodium actually do like to get together quite a bit. That's where you get salt from. Chlorine is number 17 on the periodic table. How many protons does?
17.
Very good. 17 protons. And it means it has how many electrons?
17.
Very nice. So we have 17 positive and 17 negatives. Chlorine is in group 17. So how many valence? 7. Very good. We have 7 valence. So, is it going to be easier for sodium to lose all 7 or gain 1? Gain 1. Always pick a smaller number. So, if we gain 1, How many electrons is it gonna have now? 18. What is the chloride ion's charge gonna be? -1. Very good. This is an anion. Not too bad, right? You'll get to where you look at them and you can say, well, I know that that's going to be an anion, that's going to be an anion, that's going to be a cation. But until you get comfortable with reading it like that, this is how I want you to think about doing it so you understand the process. All you're doing when you calculate the charge of the ion is counting up the number of positives versus the number of negatives, and you're going to have an overall net charge. And that will tell you what is the cation and what is the anion, which one's what, okay? Questions about that one before I move forward? Good? Okay, good deal. So when I give you your periodic table in a few minutes, you're going to write all of this down. I just wanted to show you this, though. Everything in group 1, this makes it easier, by the way. Everything in group 1 will always have a +1 charge. +2 equals 2. Skip the transition metals always. They do not, you can't figure anything out with them. +3, group 13. 14 is the weird one. You will not have anything in 14. If you have something in 14, the text or me or somebody will tell you what the charge is, because half of them are positive, half of them, are negative 4. So we really don't do anything with group 14 in this class. You go to group 15, -3, 16, -2, 17 is all going to be -1. I think boring. 13 is +3. And then finally, group 18 is 0. Why is group 18 0? It's already full. Very good. It's a noble gas. They're noble gases. They do not want to react with anything anyway. Therefore,
You said they will react with some stuff though?
under extreme circumstances, not for this purpose. Only krypton and xenon. Not any of the other ones. So if you have that question on a test and you say, and you answer it, I'm going to mark it wrong. Because for the purpose of this class, they don't react with anything. Okay? Because we don't, this is regular.
What does the periodic table have to do with chemistry?
Huh?
What is the
Did you read
chemical?
Maybe. This is how we arrange that's how you look at it. No, it's okay.
I just asked a question.
No, it's a good question. It is a major tool in chemistry. All of our elements that we study is listed in that way. And they're arranged in a way that you can use it for chemistry. And if you know how to read it, then it will tell you the properties of each one of the elements. Okay. All right. So now we're going to, now let's, hang on. We just did that one. Size of atoms. All right, you ready? Here we're going to start our trend. Size of atoms, this is your atomic radii. So, in a period, by the way, which is a period, across or up and down? Which way is the period? Across. This is the period, horizontal. Okay? Try to remember that. In a period, the radius of the atom decreases as the number increases. So what that means is as you are going along the period, they're getting smaller. As you go this way, they get smaller. So when you're looking at row 3 there, and you got sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon, as you go towards argon, they're just getting smaller. And the reason for this is you have an increased nuclear charge pulling the valences closer. So it's like having one magnet that has a positive in the middle trying to pull in one negative on the outside versus having, 8 positives in the middle trying to pull all 8 back in. The more positives you have, it's going to have a stronger pull, so therefore it shrinks the size of the atom, the radius. Okay?
So
It is bigger than, it's actually kind of small for this one, but lithium would be bigger than what? I don't know. What's lithium bigger than? Huh?
He said hydrogen.
It is bigger than hydrogen, you would be correct, but we're talking about the rows here, so what would you say lithium's bigger than? Huh? Yeah, it's bigger than helium. What else? from 3 to 10, which one's the biggest? Lithium or neon?
Neon. Lithium.
Lithium.
Yeah, lithium.
Lithium, that's what's right. Any one that you pick would have been bigger. As you go across, I said they get smaller. So the ones on the farthest left-hand side are going to be the,
So that's why the gas is included, right?
well, no, it doesn't have anything to do with it. It has to do with the nuclear charge, meaning how many positives does it have in the center? Okay? How many magnets are pulling? If I had my magnets, if I could find my magnets, I could demo that for you. So in the group, remember the groups are up and down. As you go down the group, the radius of the atom increases. So as you're going down, it increases. So it gets bigger as you move down the group. Increases should be. The reason why is that you have more energy levels. Think every single period as you go down, what's happening? You're getting another what? What do the periods tell you? The period number. 1, 2, 3, how many what? Outer bands, right? So, if lithium versus francium, which one has more rings? Francium, very good. Francium has 7, so it's going to be huge. So you got lithium here, let's just say, let me draw a picture. So if I have lithium right here, and it's got 1, 2 rings, and then I've got, let's just say cesium, because I'll run out of room if I draw francium. 1, 2, 3, 4, 5, 6. You can see that there's, this is why they get bigger. Because as you move down, you're gaining another energy level. Okay? This is atomic radii. So then, this is a picture of them, and you'll see that for the most part, they all follow the right rule. However, your noble gases, not so much. Honestly, they do their own thing. They do not follow a lot of the trends. I mean, they have the highest ionization energy, which we'll talk about in a minute. However, if you weren't looking at them, though, you would see that fluorine is really tiny. And cesium is very large. So your tiniest element is going to be either fluorine or hydrogen, because hydrogen is small. However, if we're just looking at the general trend, this is where your small one is. This is where your large one is. Okay? All right, then once again, which one has the largest atomic radius? Which one?
Lithium.
Lithium, very good, it is lithium.
Hey, I know it's lithium.
I told you that.
So in order of largest to smallest, which one has the smallest up there?
Fluorine.
Fluorine, very good. Fluorine is going to be
Hey, I
the
know it's
smallest.
fluorine.
So it would be lithium, beryllium, carbon, and then fluorine. That would be your progression from largest to smallest. Good. Good. So, next one, ionic radii. Lovely ionic radii. This is where you have to look. What happens to the parent atom when it forms an ion? Well, if you are forming a cation, when atoms lose electrons and form a positively charged ion, that would be a cation, they get smaller. The reason for this is that loss of that valence electron leaves an empty orbital. And you've got more positives in the middle. So let's just talk about lithium. Since I already have it here, it's got 3 positives and it has 2 rings in its elemental form. 2 and then 1. This is neutral lithium. So lithium only has 1 valence. Does it want to give away this 1 or gain 7?
Give it away.
Give away 1. So now look, this is the lithium ion. Let me do that. And it's just got an empty shell here. So it has 3 positives and 2 negatives. It has an overall charge of plus 1, right? You see that? Agreed? Okay. Well, if you've got more positive magnets in the center and then you do negatives, what is it going to do? It's going to start pulling everything in. So that's something you need to think about when we talk about cations. opposite is true for the anion. If it gains an electron and it's negative, then it gets bigger. Okay? It makes cation smaller. It makes the anion gets bigger. Okay? Alright. Yeah, you got it.
Oh, yeah.
Alright, so this just shows you, it's a good picture of what happens. You have the parent atom, which is the brown, that's what it was. These are cations, see they get smaller, the red shows what they turn into. So these are the anions, this is the parent atom, and then when it becomes the anion, it gets larger. So, just to show you the difference in the size and the trend. Basically, we don't draw a lot of the trends for the ionic radii because it's just easier for me to say, just know that a cation gets smaller and an anion gets larger. Okay? Alright, moving on. Electronegativity. This is probably the most important one. If you don't remember what electronegativity is, you might want to write this little definition out to the side. We kind of talked about it the other day, but electronegativity, and this is the abbreviation for it, is the ability of an element to attract an electron from another element. So, electronegativity is the ability of an element to attract an electron from another element. It basically is going to pull that one away. So, in a period, going across, the electronegativity of the atom generally increases as you move across. So as you're going from left to right, you're going to have an increase in electronegativity. Not group 18. Why? It's already full, right? It doesn't want to react with anything. It doesn't need an electron, right? That's right. It doesn't need anything. It's independent. Doesn't want anything. Doesn't need anything. So therefore, electronegativity does not apply to the noble gases. So, do it. They are. They really are. And so what happens is you have a smaller radius. The explanation, and the formal explanation, is that as you go across, you're getting a smaller radius. Your valence is closer to your nucleus, therefore it's got more pull on your electrons. And that E with a little negative is electron. Okay? In the groups, as you go up and down, your electronegativity decreases as the atomic number increases. So as you go down the group, electronegativity decreases. The reason is that the larger radius that you have, the valence is farther from the nucleus. Those electrons are farther away. So if you think about the two elements, fluorine and cesium, this is the most electronegative, this is the least electronegative. Francium too.
We have to write from the nucleus part.
Yes, I left it off, I'm sorry. I meant to put that on there.
Where?
Just write what's not written down on your notes.
Oh, got you.
Okay. So, fluorine has 9 positives, it has 2 rings, and it has 7 valence. It needs 1 more electron to make 8, right? It's very electronegative. It's highly electronegative. It will pull that electron from anything. Cesium, on the other hand, has 6 rings. And no, they're not perfect. I'm not art. I'm not good at here. And yes, it does have 55 protons and 55 electrons, but it only has how many valence? It's in group 1? 1. And you have this one lonely little electron out here. And it really does not want to be there. Cesium wants to get rid of that because right here it's got a full outer shell. And so if it gets rid of this one, then it won't be happy with its full outer shell.